All right, let's talk about a concept you probably learned on your first day of coding, but you might not be using it to its full potential. I'm talking about encapsulation. Today, we're going to blow past that simple textbook definition and see how it really acts as a critical line of defense for your code in the real world.
So, to kick things off, I've got a question for you. In a big, complex system, what's that one single line of code that could bring the whole thing crashing down? You know, the one that could do the most damage? The answer might be way simpler than you think.
And there it is. That's it, one single line, a direct assignment that sets a bank account's balance to a huge negative number. This isn't just some minor bug, this is a full-blown catastrophe waiting to happen. And it's all possible because of a really basic flaw in how the code was designed.
Now, the reason that one line is so incredibly dangerous comes down to a simple concept: direct access. It's this idea that any part of your application can just reach in and mess with critical data whenever it wants, with zero checks and zero balances.
Just look at this simple class. I mean, it seems harmless, right? But that one little word, public, that is a wide open door. It's basically an invitation saying, hey, anyone, anywhere in this entire project, feel free to come in and set this balance to whatever you want. No rules, no validation, absolutely no protection.
And here's the scary part. This risk just explodes as your project gets more complex. Imagine a team of 20 developers, or a bunch of microservices all interacting with this data. That single public field becomes a ticking time bomb. One tiny mistake from anyone on the team can trigger a production disaster that totally corrupts your data.
So, how do we defuse this bomb? Well, this is where encapsulation finally enters the picture. And you gotta stop thinking of it as just some programming term. It's our safeguard. It is the shield we build around our most important data.
And this right here is the real, practical definition that matters. We are hiding the internal data, like that balance field, and then we provide very specific, tightly controlled ways for the outside world to interact with it. The whole point is to protect that object's state from ever getting corrupted. Making your fields private is the absolute mandatory first step. It has to be done. This one tiny change immediately slams that wide open door shut. It stops illegal changes in their tracks, and, more importantly, it creates one central place where you can enforce all your business rules and validation logic. Okay, but this is usually where people complain, right? Ugh, getters and setters are just useless boilerplate code. But that is such an outdated way of thinking. Let's reframe this. They aren't boilerplate. They are powerful gatekeepers for our data.
This comparison really nails the shift in mindset. On the left, you're just mindlessly setting a value, but on the right, you're creating a control point, a special method where you can add validation checks, enforce security rules, maybe add some logging for an audit trail, and ultimately, you can guarantee that your object can never be put into some weird, inconsistent state.
So, enough with the theory, let's see how this actually plays out in the real world. We're going to walk through 3 modern backend examples where doing encapsulation right is completely non-negotiable.
First up, let's go right back to our banking disaster. We already know the problem. Letting anyone directly touch the balance is a recipe for total collapse. Well, encapsulation is the architectural solution to that problem.
Think about it. By making the balance private, we force every single interaction to go through controlled methods like deposit or withdraw. And inside those methods, we can write code to make sure a balance never goes negative and that every business rule is followed every single time. This creates a model that's secure, easy to audit, and way more maintainable in the long run.
All right, next up, a scenario that should honestly keep every developer up at night: handling user passwords. Allowing any part of your code to directly set a password as a plain string is a massive, massive security vulnerability.
Encapsulation solves this perfectly. When some code calls setPassword, our gatekeeper method jumps in. It can check if the password is strong enough, and, most importantly, it can hash it before it ever gets stored. All that critical security logic lives in one single safe place, and it's guaranteed to run every time. And for our final example, let's look at the front door of our entire system, the API request. If you don't validate the data right when it comes in, you're basically letting garbage flow into your whole application. Imagine an API call trying to process a payment with a totally invalid customer ID and a negative dollar amount. It's chaos.
By encapsulating the incoming data into a request object, we can put all our validation logic right there, in the constructor or in the setters.
This is amazing because it guarantees that by the time your business logic even sees the request, you already know it's valid. It's a powerful way to keep your system clean and robust from the outside in.
So the real key takeaway here is that encapsulation is so much more than just typing the private keyword. It's not about a keyword. It's a fundamental design principle.
I mean, this slide really says it all. Look at the left side. Without this principle, your code is fragile, it's probably full of potential security holes, and it's a complete nightmare to debug. But with it, you get data protection, centralized control, and the rock-solid foundation for secure, reliable application design.
So please remember this. Encapsulation is not some academic concept from a textbook. It's a security layer, it's a core design principle, and it's a practical, real-world safeguard that is at the very heart of every secure banking app, e-commerce site, and enterprise system out there.
And I'll just leave you with this one question to think about. After everything we've talked about, what part of your own code right now is left unguarded? What critical data is just one bad line of code away from disaster? Go find it and build a shield around it. Thanks for tuning in.